Problem 31. Which of the following compounds has one or more asymmetric centers? Remember, to find an asymmetric center, we're looking for an sp3 hybridized carbon that is attached to 4 different groups. A has one right here. B does not. B has a line of symmetry, so it does not have an asymmetric center there. C has one right here. D does not have an sp3 hybridized carbon that has 4 different groups, but E has 2. Problem 32. Draw all possible stereoisomers for each of the following. Rather than torturing you with more of my bad handwriting, I figured I would show you what the book wrote as the possible diastereomers, or excuse me, the possible stereoisomers for each of these. And I don't know why it's orange, but it is. So here's the answer for A in the Fisher projection as well as in the perspective, and B. I'll move it up so you can see C and D. Problem 33. Draw the stereoisomers of 2-methyl-cyclohexanol. So we start with our base, our hexane, and we have our alcohol group, and then 2, so we're going to go right next door for methyl. So this is a cis, 2. Now, drawn this way, this carbon is at an R and this one is an S. So we can also do this where this carbon is an R and this one is an S. Both of these are cis 2-methyl-cyclohexanol. And then there's the trans version, where they're both R. And then they're both S. So these are trans 2-methyl-cyclohexanol. Problem 34. Of the possible cyclooctanes that have one chloro and one methyl substituent, which ones do not have any asymmetric centers? Well, to draw ones without asymmetric centers might seem challenging, but really what you need to do is find some symmetry. I finally got smart and used the shape drawing tool instead of torturing you anymore. So we need to find some symmetry. If I can draw a line of symmetry through these 2 vertices here, maybe I ought to be using a different color, and put my chlorine here and my methyl here, then these 2 groups are identical, and therefore this is not an asymmetric center. So another way we could do this would be to have chlorine here and methyl here, or one behind and one in front. So these 3 cyclooctanes do not have any asymmetric centers. Problem 35. In order to draw a diastereomer for any of these compounds, you just need to switch any one pair of substituents that are bonded to any of the asymmetric centers. So your answer may look a little bit different than mine, but that doesn't mean it's not valid if you've switched any pair. So for example, I'm going to switch these 2 here. So here's where I switched. And for B, I'm going to rotate here. And for C, I'm going to make this trans. And for D, I'm going to flip, have OH coming out here, and I'm going to have CH3 going behind. Problem 36. Indicate whether each of the structures in the second row is an enantiomer of, a diastereomer of, or identical to the structure in the top row. Well, this might be another case for the molecular model kit if you can't visualize this very well. But A is identical. It's just turned one click over. B, on the other hand, is an enantiomer. C is a diastereomer. And D, again, is identical.